Welcome to part 2 of 3 of my slightly more advanced trig identity video series. If you are just joining me, you probably don't want to start with this one. You probably want to start with the previous one that I just uploaded, part 1 of 3. Or if you're kind of even completely brand new to verifying trig identities, you want to go back to my more basic 3-part series that I uploaded a few weeks ago. In those videos I did a bunch of examples that are much easier than these. In this video I'm going to go through 3 trig identities, each of which involve a bunch of steps. We have a ton of algebra, a ton of sort of Pythagorean identities. We have some algebra tricks. We have maybe even some odd, even, and maybe some double angle formulas. So there's a lot going on in these. So like I said, this is probably not the best video to start with if you are just starting off. But here we go. I'm going to go through 3 of these things. Let's start with this one. I definitely think the left side is more complicated, so I'm going to try to get my left side to look like my right side. So I'm going to go ahead and write my right side down. And maybe even copy it a bunch of times. I always want to either rewrite that or copy it down again, just so I have a really good idea of what's going on. It helps me to stay organized. This one's going to be, I don't know, about 6 or 7 steps maybe not even that. The trick here is to understand that the whole denominator down here is really just a quadratic. All right, and that quadratic needs to be factored. So if you want to think about the denominator as x squared plus 3x plus 2, how would you factor that? Well, you would say x plus 2 times quantity x plus 1. And this is the same thing. The only difference is instead of x squared, it's cosine x squared. So that means I'm going to put cosine x here and here. I'm going to put 2 here, 1 here, plus and plus. If I FOIL those together, I should get exactly what I started with. What that does for me is allows me to see that my numerator now, if it's sine squared, I can change that using Pythagorean into 1 minus cosine squared x. The reason I did that is because my denominator is only cosines, and I'd like to have some sort of cancellation potential. So let me rewrite my denominator. All right, next, more algebra. I need to recognize that my numerator is difference of 2 squares. In other words, it's basically like 1 minus x squared, or x squared minus 9 or something like that. So we need to factor that. X squared minus 9 will be x plus 3, x minus 3. This one would be 1 minus x, 1 plus x. So I'm going to use that same pattern for the numerator. 1 plus cosine x, 1 minus cosine x. My denominator stays the same. And I'm looking for cancellation here. Do I see any binomials that are on the top and the bottom? Well, this is exactly the same as this. 1 plus cosine, cosine plus 1. So let me rewrite my numerator. And I can see that I'm done. All right, I'm not going to go through this commutative property here. You can just move those around if you want to, but I'm going to stop right there. All right, so I used Pythagorean, I used 2 algebra tricks, and I'm done. Let's move on. Fairly simple to see that the left side is way more complicated, so what I'm going to do is try to get my whole left side to be that, which seems kind of unbelievable when you look at it, but let's give it a shot. This one's going to be quite a few steps. I think maybe about 9 or 10. So I'm just going to copy that down a bunch of times and see if I can get the left-hand side to start looking like that right-hand side. First thing I'm going to do is use some algebra. I have two fractions that are going to be added together, I need common denominators, right? So if we kind of take a step backwards and go back to, if we had like 3 over 5 plus 2 over 7, how do we add those together? Well, we change those denominators to be the same. And the easiest way to change those denominators to be the same is to multiply them together. It's not always going to get you the lowest common denominator, but it'll get you a common denominator. In this case, it is the lowest. 7 times 5 is 35. So how did I change 5 to make it 35? Well, I multiplied it by 7, of course, so I need to take this and multiply up here. 7 times 3 is 21. How did I get 7 to be 35? Well, I multiplied it by 5, of course. 5 times 2 is 10. I have common denominators, so I'll add my numerators and keep the denominators. We're using that same pattern here. So let's just multiply our denominators together. When I do that, I simply get 1 plus secant theta times tangent of theta. I'll put that in parentheses. Same thing here. 1 plus secant theta times tangent of theta. So my numerator changed from this to this. And how did I do that? I multiplied it by tangent. So now I need to multiply tangent by this, of course. Tangent squared theta. Same deal over here, right? This denominator, to get here, I multiplied it by 1 plus secant theta. I need to do the same thing to the top. So I'll take this and multiply it up here. So it's 1 plus secant theta times itself. And I'm ready to continue. I'll FOIL this out. Expand that binomial. I get tangent squared theta plus this thing is, let's see, first times first is 1. Outside is secant theta, inside is secant theta, so that's 2 secant theta plus secant squared theta. And I'm going to combine these denominators together. When you add fractions, you just keep the denominator and add your numerators. Okay? You can see a nice Pythagorean identity right here. That is equal to secant theta, right? Tangent squared theta plus 1 is equal to secant theta, secant squared theta, pardon me. So I'll make that substitution now. I'll rewrite the entire numerator and the denominator as well. All right, let's keep going. Sorry, the bell rang there. When we keep going here, I need to now combine, let's see, secant squared plus secant squared. That's 2 secant squared theta plus 2 secant theta all over 1 plus secant theta tangent theta. Now you'll notice that I'm not distributing this into here. A lot of times you don't want to do that because eventually you're going to notice that this binomial a lot of times is going to cancel out with something in the numerator. So let's keep that separate. Keep the binomial separate from the tangent for a minute. All right, in my numerator, notice that we have two terms. They both have a 2 in them, and they both have a secant in them. So let's take that out. We're factoring out a greatest common factor. So if I take a 2 secant theta out of the numerator, what that's leaving me with is 1 secant plus 1. Just factoring out a common factor. And look at this, we have a cancellation. Secant theta plus 1, 1 plus secant theta. They're the same thing. Cancel them out. My numerator is 2 secant theta. My denominator is tangent of theta. I need to get that to be 2 cosecant theta. All right, so let's rewrite that. 2 cosecant theta. And remember, when you divide by something, it's the same as multiplying by its reciprocal. Well, the reciprocal of tangent is cotangent. So instead of dividing by tangent, I can multiply by cotangent. turn them into sines and cosines. This is 1 over cosine, and this is cosine over sine. And you can probably see that we're pretty much finished. I've got cosine and cosine to cancel. So that leaves me with 2 over sine theta. And does that equal 2 cosecant theta? Definitely. Because remember, 1 over sine theta is cosecant theta. So I'm finished. Let's move on. At this point, you probably want to try this one on your own. Pause it, give it a shot, and then press play, see if you got it right. I'm going to change my left-hand side here. And I'm going to use a trick that I used in my previous video. When I see a denominator that doesn't have any squareds in it, I want to try to get it to have squareds in it. So what I'm going to do is multiply the top and bottom by its conjugate, 1 plus cosine beta. 1 plus cosine beta. The reason I did that, I can do that because it's the same thing on the top and the bottom of a fraction, so that's basically just 1. When I multiply a fraction by 1, it doesn't change the value of it, so this is okay to multiply by this fraction because it's just 1. It's a fancier way of writing 1, of course. So let's keep the numerator separate. Let's FOIL the bottom. First times first. Outside is negative cosine beta, inside is cosine beta. They cancel. So it's just going to be first and then the last times the last is cosine squared beta. So I need to get that to be 1 plus cosine beta over sine beta. Alright, well, at this point I did this verification 2 different ways, and I'm not going to show you both, but I will kind of discuss it. The first way I did it a couple months ago is I distributed these together. So that gave me sine beta plus cosine beta sine beta, right? And then I ended up having to sort of undo that at the end anyway. So it's generally, not always, but generally that is not what you want to do. You want to keep them separate. Don't distribute, because you might see cancellation occur on either this or this. So let's leave those alone, and let's just change that denominator. Let's change my denominator, of course, using Pythagorean. 1 plus cosine squared, excuse me, 1 minus cosine squared is just sine squared. And sure enough, we have a cancellation. I have a sine on the top, and I have 2 sines on the bottom, so one of those will cancel. I get 1 plus cosine beta over sine beta. So that one wasn't too difficult, I guess. A little bit of algebra. So that takes care of part 2 of 3. In the next one, I'm going to run through 4 proofs, so it might be a little bit longer, but I hope you enjoyed this one, and as always, just keep working at these things. If you can't get them right away, that's pretty normal. It doesn't mean that you're necessarily struggling with the content. It just means that you need to start to develop patterns and tricks and start to see shortcuts emerge. And if you keep practicing, like with most math, you're going to get way better at these things. So keep working and look forward to part 3. Thanks.